Hi everyone, my name's Louisa, and today I'm going to be walking you through a couple exercises and how we can apply Ohm's law to answer some sort of simple questions about the properties of a certain resistor. Alright, so here's a pretty simple problem. We're looking at a 10-volt battery, which is right here, and the resistor we're looking at has a resistance of 5 ohms, and we want to find the current flowing through the resistor. So in order to apply Ohm's law, which as we know is V equals I times R, or voltage equals current times resistance, we need to know the voltage going through the battery, the voltage going through the resistor, the resistance of the resistor, and that information will be enough for us to find out the current. So in this problem, there's only one resistor in this circuit, and that means that the full voltage of the battery is going through that resistor. I'm going to get more into detail about this in a later lecture, but the important thing to understand right now is that it takes a certain amount of voltage for current to pass through this resistor, and by the time current passes through that resistor, the voltage has completely dropped down to 0. So we say that the voltage drop through this resistor is 10 volts. So we can go ahead and say that V equals 10 volts. And we know the resistance, it's given to us, so we know that R equals 5 ohms. So I, we're just going to rewrite this equation in a way that isolates I. Let me do capital I just to be consistent. And we're going to say I equals V over R, and that is 10 volts over 5 ohms, and that gives us 2 amperes. Let's take another look at a slightly different problem where we're going to look for the resistance. So in this problem we're going to be trying to solve for R, the resistance of the resistor. We know that the voltage of the battery is 25 volts, and we're given that the current is 100 amperes, which is a very high current, but we're just going to go with it. So we're going to first think about how much voltage is actually going through the resistor. And just like in the last problem, since there's only one resistor, the voltage must completely drop to 0 when it passes through. So we can say that the voltage going through the resistor is equal to 25 volts. We're given that the current through the entire circuit is 100 amperes, and since there's only one resistor in this circuit, we know that the current going through that resistor is also 100 amperes. So now we can solve for R by using V equals I times R. We're going to isolate R, and we're going to do R equals V over I, which is the same as saying it's 25 volts over 100 amperes, and that's the same as 1 over 4 ohms. So these have just been a couple of simple examples of how you can apply Ohm's law when there's only one resistor in a circuit. In the next videos, we're going to take a look at some more complicated examples using multiple resistors.